Okay, then this is the solution for this one. I think we can now summarize that what you have learned up to this point. If you don't have any kind of good news, could you please start the recording? Yeah. Then normally that next thing is that 5-variable map, but basically we don't use Carnot method for the 5 variables. Imagine that you have to draw a 32 grid map. It's a huge one. Okay, then you have to combine, you have to think about that combining 2 maps together, but then it's a little bit difficult. Because of that, in your scope we are not going to consider that one. Actually we have different methods for the Boolean equations when we have more than 4 variables. Okay, then we have to consider those things there. We can now summarize these things that what we have discussed so far. Then from the Carnot map method, that what so far we have discussed, actually that the point is that all the time that you can, that one grid can be covered many times. But remember, you can do this one, and if you have to do this one, if it helps minimization only. Okay. Second point, then if you want, you can connect edges also. Third one, then if you want, then so far that what we have done, so far we have minimized equation considering ones. For example, if you consider a map like this, then what is this? Then we can minimize this. We can make this map like this. This is A bar A, this is B bar B, and this one. Okay. Then what is the solution for this one? We can make this group. This is A bar, and this one is B bar. Then F equals A bar plus B bar. Okay. Then what about that if you take this one? What is this? This is AB. Then if you take this AB, that is what? This is F bar, because we have covered zeros. Then zeros means it's F bar. Then F bar equals AB. It's a more simplified version than previous one. Then this indicates that then for either one or zero, You can cover, if you want, you can cover ones or you can cover zeros. But remember that when you cover ones, that is for F. When you cover zeros, that is for F bar. Okay. Then if you think that the F bar solution is very minimized one, then you can. But is it wrong, this one? When you have F bar, it's a matter of sending it through a NOT gate only. Then after having this one, here you have only single gate, another NOT gate, which is 2 gates. But here you need 3 gates. Okay. Then fourth one, the X don't care state. Can be considered either 1 or 0. Then what is this don't care state? We didn't discuss about this, but if you want, you can consider this X as either 1 or 0. It doesn't matter. Okay. Then don't care state can be either 1 or 0. Then what is this don't care state? This don't care state means, but for example, that if you consider maybe that, assume that you want to send a, you want to find that water level of a water tank. Okay. Then assume that you have a water tank like this. And we have fixed 3 sensors there to check the water level. Okay. Okay, then assume that for the disturbance that we have phase 3 water level sensors like this. Assume like that. Then we'll make a truth table to check the water level of the tank. Then depending on the water level, we can do something. We assume that we want to have this output. Then we can find this output. We want to find the water level. Then based on the water level, assume that we want to turn on a motor or something like that. Then these are the all possible combinations here. Okay. Now 0, 0, 0 means there is no water. Then here we can turn on motor. Then here 0, 0, 1. It's okay. But what about this one? Can you check this condition? This is okay. Here at B we have water, but at C we don't have water. Is this combination possible? And what about this combination? This one, this one. Is it possible combination in this practical situation? No, these conditions never come true. Because of that, we don't care about this. Why? We know for sure these are not coming. This will not happen. But especially in this type of cases, it depends on the case. It depends on the case. According to the case, then if you include, if you want that you can include those conditions to your equation, then there is no harm. But if you want, you can exclude those things from your map. It doesn't matter. For example, assume that you have a map like this. And this is A, B, C, B bar, C bar, B, C. This one, this is A bar, A. Okay. Then here you have 1, 1. This is X. This is 1. Okay. Then this is X. This is 0, 0, 0. Okay. Now you want to minimize this map. Then if you consider this X as 1, what can we do? We can make a group like this. Then we have this single group. This is A bar. Okay. Otherwise that we have to make two groups here. But using a single group, we can minimize this one, this A bar. But here, another problem is there that here also we have X. But this X we can consider as 0. Then considering this X as 0, then what can we do? We can forget about this one. We can remove this. Why? We can stay without considering this one for minimization. Why is it 0? Zeros we are not taking. But the problem is that the same map, in one place we consider this X as 0, in another place we consider this X as 1. Is it possible? Yes, it's possible. It's not fair, but for the map, it's possible. Why? These are don't care states. These conditions are never come true. Then they are not coming. Because of that, whatever the thing you need, you can do. Then the solution for this one is only the same. Then if you want, you can consider this X as 1 or this X as 0. Then X means don't care state. Okay. Okay, shall I show you a question having this one? Maybe. Okay, anyway, that I couldn't find it. I will give you an example. Okay, you can try this one. I am combining couple of things here. Then I think we did not try this type of question. Then you can try it. Shall we try this one? Okay, then sorry for the disturbance. I think here I think I have marked this this four variable terms. I have marked this one 1, 2, 3, 4, 5. Here the five ones are there. So you can see that this X don't care terms also I have marked. Then what about this one? These ones I think we haven't discussed this type of things. Okay, but this is also possible. This is not a single grid. Actually, instead of that one, that is an area. So some kind of area. A, C, D bar. Where is that one? A means this one. C, D bar. C, D bar is this one. This is A, C, D. A, C, D bar is this one. It's not a single grid. It's an area. Okay. Then this next one, A bar, C bar, D. A bar is these two rows. C bar, D, this one. And third one, B bar, C, D. B bar means these two, and CD means this one. These ones. Okay, that is a map. Okay, then how can we minimize this? Then here, with this, I think you can see, if you consider this X as 1, okay, if you consider this X as 1, then we can cover this one or this one like this. Okay. Okay, I'll take this group first. Okay, no. We can take this one also as, this one also we can consider as 1. Then okay, the question is asked that, can you explain how these 3 variables were marked? Okay, I'll explain it again. You can see this one. It's ACD bar. See this ACD bar. ACD bar is not a single grid. It's an area. Where is ACD bar? A means these two rows. CD bar, this one. This is ACD bar. Okay, then this is ACD bar. This one. Next one, A bar, C bar, D. A bar, C bar, D. This one, A bar, C bar, D. A bar means these two rows. C bar, D is this two. Okay. Then next thing, this one, B bar, C, D. B bar, C, D. B bar means these two rows. Then C, D means this one. These two. Ajay, is it okay? Yes. Okay. Then we can consider this, both x's we can consider as 1. Then how can we make a group? You can see we can cover this one and this one together. Then what is the name for this one? It's B bar. Okay, then we can take this group. What is this? It's C bar, D bar. and we have to cover these three. This is A, C. Only this one is remaining now. We can combine what is this? This is A bar C bar. Okay, then minimize equation is F equals B bar AC A bar C bar, then C bar D bar. But from the map, we can minimize up to this level. This is the way, okay, we can minimize. Is it okay that any question regarding this Kana map? We are going to finish this one. We have to start new section. Sumalki, that you are referring this one that we have minimized this equation for F. Sorry. This one is, you can change this one. Okay, thank you very much for you. Here it's F, it's not F bar. Otherwise that you might think that F bar is also having this type of thing. F might not have. No, this is F. Sorry that I have mentioned this as F bar is a mistake. Thank you very much, Sumalki. Okay, then if you don't have any question, then we can start the other one, the section. The next one is actually that we have to discuss about combinational circuit, but when you consider the digital electronics entire spectrum of this one, this one, we can divide this entire thing into two. The meaning is that we have one side, they are combinational circuit. The other side, we have sequential circuits. Okay. Now we are going to talk about combinational circuits. Actually, what is a combinational circuit? That when you consider a combination circuit like this, it's having several input lines. It's having multiple output lines also. Okay. Then like that. Then many output lines are multiple input, multiple output circuit. But when that this circuit outputs are giving particular output patterns, they are totally based on the present input values. That is a combinational circuit. What does it mean? What is that? Okay, if it is a combinational circuit, its particular output pattern for a particular moment, this output pattern or value totally depend on the present input values. Its output value totally depend on present input values. What is the meaning of that? Did you find any type of circuit like this? Okay, shall we go back to our previous notes? Okay. What about this one? We can take. Okay, this is also okay. This circuit is having that. This is our first circuit. Then when do A open, B close like that, we had this truth table. In this truth table, this output M is 1 here. Why? During that time, the inputs are A, 1, B, 0. Because of this particular input value, this output is 1. Because here, A is 0, B is 0. Because of that, M is 0. The output value totally depend on present input values. When these are having 1, 1, then output will be 1. Like that. Then if that's so, then this is what type of circuit is this? This is a combinational circuit. Why? The particular output value totally depend on the present input value. Then whatever the circuits so far we have discussed, all those circuits are falling into the category combinational circuits. Is it okay? Then shall we go this one? Here we have certain conditions, and these are the truth. This is the truth table. We prepared this truth table based on these conditions. Okay, then here E is 1, here E is 1, E is 1 in 4 places. Why those ones are there? Because of the particular input combination. Here A0, B0, C0. Because of that, E is 1. Here 1, 1, 1. When the combination is 1, 1, 1, output is 0. Nothing else. Because of that, then all the circuits we have discussed so far, they are combinational circuits. Okay. Then combinational circuits are not a new thing to you. In other words, the designing procedure of combinational circuit is not a new thing to you. Okay. Then this designing procedure, any designing any combinational circuits you can design. Why? You know how to design a combinational circuit. Then there is no problem. Okay. Okay, now when we come to combinational circuits, we have a lot of standard circuits there as combinational circuits. Why standard circuits? But when we do the designs, people have realized that they have to design some kind of modules again and again and again. Then after having seen those things, that they have considered those things that, okay, we can make those circuits before we start designing all the circuits. Then they are making these ready-made circuits. That once that when you want to design a circuit, then if those one of these modules are matching with your design, then you can take that part as it is. Then rest of the circuit can be designed. Okay. Then without designing the entire thing, you can consider the standard blocks of those readily available standard blocks. Then you can take one of these standard block and you can add other parts to the circuit in order to fulfill your requirement. Then you can make the entire circuit, but if it is possible, we can use standard blocks there. Okay, then from this point onwards that we are going to discuss about these some of the standard blocks there. Okay, the very common standard blocks are, the first one we are going to start is decoders. Decoders. Okay, among these decoders that we are going to discuss standard decoders. Standard decoders. Under the standard decoders, the first very simple standard decoder is 2 to 4 decoder. Okay. I'll draw the 2 to 4 decoder block diagram. Here we have 2 inputs. And this side we have 4 output lines. This Y0, Y1, Y2, and Y3. Okay. Then truth table is this side we have 2 input terminals. Then we have 2 input columns. The other side we have 4 output columns like this. And these are the possible combinations for A and B. And then when the first combination is there, this is the output pattern. In the second combination, this is the output. The third combination, we can observe this output. For the fourth one, this is the final output pattern. Okay. You can see there is a pattern here. for one combination, one output line is having one at a time. Okay. But when you want to design a combinational circuit, when you want to design whatever the type of circuit, so far we have discussed, what are the steps of standard designing procedure? First, we identify inputs and outputs, then we draw a block diagram to show those things. Then, understanding the conditions, then we prepare a truth table to include those conditions. Then now, after coming to the truth table means that when we have done 50% of this, then what is next? Then we have to write output Boolean equations. Then if possible, we have to minimize those equations. Then we are drawing the circuit using basic logic gates for the minimize equation. Those are the 5 steps. Okay. Then first one is there, block diagram is there. Second one, truth table is here. You can see the truth table. Then third step is writing output equations. Shall we write output equations? How many outputs are here? How many outputs? Four outputs there. Okay. Then if you have 4 outputs, then how many output equations we have to write? How many output equations? Yes, we have to write 4 output equations. Okay. Why? For each and every output line, we have to write separate equation. Shall we try to write those equations? Can you take a couple of minutes and try to write those output equations? Yes, it's good then. What is Y0? Y0 is, we have only single one. That is A bar B bar. What is Y1? Is A bar B. Okay. What is Y2? A B bar. Then Y3, A B. Okay. Then shall we draw the circuit? We need both A and B. And these are the two starting points. We need A bar also. And we need B bar also. Then we can make first term. First term is A bar B bar, that is Y0. Okay. Then this is Y0. Okay, next one. A bar B. This is Y1. A B bar. Y2. This is Y3. That is AB. Okay, when it comes to standard decoders, then it's 2 to 4 decoder. It's a very simple one. You can understand the truth table and block diagram also. Then based on the number of output lines we have to write output equations for each and every output line. Then we can draw the circuit. But is it possible to minimize these equations? No, it's not possible to minimize these equations because all these equations are having single term per equation. Then it's not possible. At least to minimize the equation, we have to have at least 2 terms there. Okay. Then if you don't have any question, then we can try next decode. What is next decode? The previous one is 2 to 4 decode. Then what would be the next? Now we know 2 to 4. Then what will be the next decoder? Can you guess? What are the things we can improve? What are the things we can do to advance this one? How can we expand this? Yes, we can increase this number of inputs to 3. When you increase this number of inputs to 3, how many combinations are there? 8. 2 to the power 3 combinations are there. Then next decode is through 3 to 8 decode. Okay, then can you guess the truth table? How many input columns are there? 3. And then how many output columns are there? 8. What are those things? Then y0, y1, y2, y3, y4, y5, y7. Okay. And there is a pattern. You can find this pattern also. When you look at the previous one, you can find this one. Here we are writing this one like this. Okay. Can you complete the other side? Okay, they can simply you have to follow the pattern. Then you can fill the output values of this truth table. Then what is next? Try to write output equation for this one. If it is possible, minimize them and draw the circuit using basic logic. Okay. I think this is not a difficult thing. And we can write output equations. Okay, then can you draw the circuit? Did you find any difficulties when you draw this circuit? Okay. Is it okay? Can you draw the circuit like this? Okay, if you are okay with 3 to 8 decoder, then next decoders will be then 4 to 16 decoder, then 5 to 32 decoder. Likewise, then when you go like this, 8 to 256 decoder. What do you think? Is it possible? Is it practical to have this type of decoders, 10 to 1024 decoder? Is it practical? What do you think that 10 to 1024 decoder, if you have 11 inputs, then 11 to 2048 number of lines, output lines are there? A huge number of lines are there. What do you think that? Is it practical to have this type of circuits? Okay, I think all of you are using computers. It may be laptop or desktop or whatever the thing. You are using computers. Okay, at the moment, that how much of memories you are having with your computer? Ajay, how much of memory capacity you are having with your computer? I mean RAM. Anyone knows the memory capacity of your computer? At least can anyone type your memory capacity of your computer to all of us? Is RAM disk, RAM capacity? Yes, 4 GB. Yeah, 8 GB, 4 GB, the type of memory capacities are there. Okay, if your computer is having, okay, 1 kilobyte of memory. If your computer is having 1 kilobyte of memory, 1 kilobyte means 1024 bytes. Okay, 1024 bytes. If you want to make 1 kilobyte of memory, assume that your computer is having only 1 kilobyte of memory. Then to make 1 kilobyte memory chip, this is 1 kilobyte memory chip. To make this 1 kilobyte memory chip, you need 10 to 1024 decode. Then understand how this how this circuit is practical. Okay, and at least that if you want to make 1 megabyte of memory, 1 megabyte memory, you need 20 to 1 million decode. This line. Then if you line, you can come down. Then if you make 30 to 1 billion decode, then you can make 1 GB memory. Okay, then imagine that how these decoders are so important and how many line capacity is there. How many number of lines are there with these decoders? It's okay. Then decoders are really practical circuits. Without having decoders, we can't make memories. Then when the memory is not there, we don't have computers, we don't have mobile phones, and many more digital circuits, many more digital systems are not there when we don't have memories. Then to make memories, we need decoders. But we are not going to discuss much more about these things because we don't have much more enough time to discuss those things. For the moment, we stick to this point and we restrict up to this level. And these are the decoders, standard decoders. Okay. Then our next one is, if the standard decoders are available, definitely there should be non-standard decoders. And what is non-standard decoder? What is non-standard decoder? What does it mean? Okay. Any circuit, anyone any circuit is having a different truth table than this For example, you can see this truth table. Okay, this truth table is this 2 to 4 decoder. It's 2 to 4 decoder truth table. Okay. Okay, then this is standard decoder. If it's a non-standard decoder, there may be 2 inputs and 4 output lines, but truth table is different. Okay. Sometimes then here, shall we use a different color? You can easily see this. Then truth table is different. Then if you have when you have this type of truth table, other than standard decoder, this is a 2 to 4 decoder. Then if you want that, you can have 2 to 4 2 input lines and 4 output lines, or maybe 2 input lines and 3 output lines. Then if you deviate from the standard values, if you deviate from the standard in number of inputs and number of output lines, and if you deviate from the standard truth table, it's a non-standard decoder. Very simple terms, it's a non-standard decoder. Okay, this is a kind of non-standard decoder. We don't know the function, but it's again, it's a non-standard decoder. Then how can we make this one? Like previous ones also, we can write output equation, then y0, this time we have a bar, b bar, a b. Y1, we have now 3 ones. This is a bar, b bar, a bar, b. Y2, there is no change. A b bar. Y3, we have 3 terms. A bar, b bar, a bar, b, a b, like that. Now we can minimize these equations. Okay, this is exclusive no. This is a bar. We can take this one as it is. This is a bar plus b. Like us, we can minimize. Then we can draw the circuit for this minimize equations. This is a non-standard decoder. And many non-standard decoder types are there. For example, binary to decimal decoder, binary to gray decoder, and BC to 7-segment decoder. Like that, many non-standard decoder types are available. Is it okay? Actually, we are a bit behind the schedule. Then I will arrange, after discussing with the staff, then I will arrange extra couple of lectures to cover up the things. And until that we can go according to the timetable. I think these days, luckily that today morning we didn't have a lecture. Otherwise, we can't do that because today morning we had a power cut. This may be over, maybe we don't know that how many days they will take to stop this one. Anyway, we'll do like this. At the end, I will take extra time to cover up the things. Okay, if you don't have any questions or in anything, then we can stop the lecture now. We can meet next Monday evening. Okay. Until that, thank you very much for your participation, for your time. Be safe and take care of yourself. Okay. Have a nice time. Thank you very much.
Thank you, sir.